Hey guys, can you hear me? Yeah? Okay, cool. So my name is Krzysztof Zabłocki, and I work for Lextech Global Services. I also have my own company called Pixel. When I did the app Foldify, probably heard about that. And today I'm going to talk about behaviors, which is a concept. Well, you probably heard about ideas like that before. It's like just separating the code and having smaller pieces. But behaviors built on composition to create pretty cool stuff that can pretty much remove some of your work and put it on some other people, which is always great. So you can delegate work. And I'm going to get into details. I also wrote an article about it on Objective-CIO architecture series. So you could read that after the talk if you didn't. Okay, so what is a behavior? A behavior is a small and self-contained class. So it's not going to be some huge-ass view controller. It's not going to be 1,000 lines of code. At least it shouldn't. It should be a very small piece of code that does just one thing. It usually focuses on user interaction. So what you are aiming for is, for example, drag and drop, right? Very common in iOS apps. You can drag some item, put it somewhere else. So that would be a behavior. So you can drag from point A to point B. You have some region. You can drop the stuff, and then you would get some event. So that can be expressed as behavior very easily. I actually am doing that in a new app I'm going to release soon. And because of that, it's also very specific. So it would never be doing two things. It would be only focusing on just one specific behavior or specific function. So it's basically small, user interface driven usually, and very specific. So there is no ambiguity in what it does. And the question is, okay, we have this kind of behaviors or whatever we call it. Chris called it intentions. He had a very similar concept. My build on some of more advanced features you can use. But why should you use behaviors? Why should you care about it, right? So as developers, we have to maintain our code, right? It's the biggest challenge is not writing the code, because when you write it fresh, you know about it, you know how it works, you know why it works the way it works and how to change it. But the project don't usually last 2 weeks. They usually last months or even years if you have your own product, if you work for a product company. So what really matters is the quality of the code we deliver. And if you talk about quality, you have to think about keeping the code clean, readable, hopefully without too much dependencies, because that always leads to mess. And when you have a class that brings up delegate or some other singletons, it usually not a good sign, right? So with behaviors, we want to focus on improving the quality of our code, but also what's really cool about it, and this is the reason why I actually created the concept, is being more effective, especially if you work in a smaller team. So for example, my company is me from engineering and 2 designers. So as you can imagine, it's kind of lots of work for me to create a new app because I have to code everything myself, right? And the designers just do the graphics and they are done. And that's like, how do we share, how do we split shares and stuff like that? It's kind of complicated. So if you are working in a smaller team and you have designers or other people that are not necessarily programmers, behaviors can make the whole team more effective. So basically what you will do, you will create a behavior which is like a class or a component, and then you can give it to those people, and they can actually configure your application, change its behavior, what happens in the app, and stuff like that, without actually writing code, because we will be leveraging InterfaceBuilder and storyboards. And not to scare you, if you don't use InterfaceBuilder and storyboards, you could still use behaviors from code, and it would look similar to the way that you normally write reactive Cocoa. So like with reactive Cocoa, you usually have one configure method, and then you set up the whole pattern of the application. And with behavior, you could get the same benefits. So you'd have a setup method, you would configure the behaviors, and you will be ready to go. Although I personally prefer to use visual tools, because then I can ask designers to do the work for me. So by quality, I mean having the clean code. So I want to have small classes. I want to have code that's easy to maintain. So I don't want to be like, when I need to change a specific behavior, I don't want to read implementation detail that's about something else, right? I want it just focused. I open a class and I see, okay, this is what it's doing. And I know how to change it because it's very easy to keep that small amount of code in memory. And as you know, if you have to read a lot of code, it's not that easy to actually like understand everything. That's why when you give a developer a code review and you give him 1,000 lines to review, he's gonna find 10 problems. If you give them 100 lines of code to review, they're still gonna find 10 problems. So you wanna keep the code as small as possible because everyone makes mistakes, and if you don't write code, then less possibility for mistake. And then it's testing, because the objects are small and they have a public interface. You can do black box testing, so you can just test the inputs and outputs of the behavior, and if something is called or not, it's very easy to test because it's small. The interface is usually very light as well, so you have like you connect maybe 2 or 3 objects. You configure like 4 or 5 properties. That's quite easy to cover with testing. And what's really cool about it, you can actually share those behaviors because of their very like targeted role. They usually don't depend on your application logic. So if I have a drag and drop controller, that doesn't matter if I'm using it in Foldify or if I'm using it in other app I'm doing, right? It's still the same behavior. Like I want to be able to drag an object. Maybe I want a different animation or something, but that's just configuration. And that's when composition really has its power. Is if you think about it, sure, you could do subclasses, and this is like the common approach, right? You do lots of subclasses and you have the hierarchy tree. But then if you ever did a big project, you know that at some point it's kind of hard to choose where to put a function, because you have this class which is describing an object, and then you have a specific subclass that does something else. And now you have like the problem happens when you have multiple subclasses, and then you have a new function you want to add, and it actually should affect few objects, few subclasses, but they don't have common parent, and it just gets messy. That's why games very often use composition instead of inheritance. Like if you look at Unity, for example, they use entity systems. An entity system is basically using composition. So you have a base class, which is like an object, and then you can configure different components for that object. And it's very easy to evolve a code base that's based on composition. And behavior is composition, which means if you implement, for one app, you implement like 5 different behaviors, it's a very big chance you can reuse them without changing any code in a different app. And now you have that already tested. You already used it. You know how to use it. Your team knows how to configure it. And well, that's, in my book, that's win-win, because it's really easy to reuse this kind of code. And when we talk about iOS apps, we have MVC, right? Model View Controller. And the problem with Model View Controller or MVC in iOS, it usually turns to Massive View Controller, which is common. It was like the first issue in Objective-C was Massive View Controllers. And this is something that I saw many times when I was I was lead engineer in London, and we were reviewing other agencies' codes, and then you get a project with a view controller that has like 2,000 lines of code. That's not only is that hard to understand for someone joining the project, if you think about it, but it's also like try refactoring that. It gets messy, right? And then you have to deal with all of the changes, and it's usually not tested, because personally I wouldn't test this kind of class because it would scare the shit out of me. Come on, it's like 2,000 lines of code, bunch of cases, because everything is dependent on something else. It's really hard. And if the guys actually separated, like have different data sources, different delegates, or even like functions, like functionality separated, so basically adhering to DRY and SRP, so single responsibility principle, they would have smaller classes. And then if you have like 200 lines of code, it's very easy to test, because they usually have like maybe few cases you need to consider, some configuration, something like that. It's very easy to test this kind of code. And this is the aim of like using composition and behavior. And then if you have the small pieces, then you can avoid the dependency. because the cases are just configuration issues. So you just configure it differently for a different app or different screen, instead of having a bunch of if statement in your main controller. So I can grab a class from one project and bring it to another without any code changes. And this is actually what I did in a few projects we've been working recently. And effectiveness. So non-developer can modify the whole behavior, which is really cool when we work with designers. So actually, I'm working on a kids app right now, and we're just going to release this month. And it was really fun app to work because I used like maybe 70–80% of the app is made with behaviors. But what's really cool about it is I created a screen, right? I created a menu view controller, and that screen for like 3 months was UI view controller class. It wasn't even subclassed. It was having some buttons, animations, and stuff. But I first committed into the repository, and my designer grabbed it, like git pull from his own computer. He did some tweaks. I explained to him how to use InterfaceBuilder. And then the next day, I pulled the changes, and I opened the app, and it's like, something is flying in, something is happening here. And I was like, what? It was really great because I didn't need to do that work, right? So they kind of helped me out a lot when doing this app. And it's really cool when you get an issue, like on Jira from your designer. When you work in smaller teams, it's designers giving you issues, right? So he gives me an issue like, we need this. And I just do reassign. You can do this. That's really, really cool. And when we talk about behaviors and how we can achieve all of those things I described, we need to talk about how to create a behavior. Because it's not something you need to grab from my GitHub. It's not some library that does the magic. There are 3 basic principles I use to actually get those kind of objects in place. And they're quite easy. And how many of you actually use InterfaceBuilder every day? Okay, so it's a good bunch of people. And runtime attributes, right? So this is something I actually was surprised not very many people use. But with, and this is actually an argument why people don't use InterfaceBuilder. Oh, that was weird. That's true. Did the projector die? Technical difficulties. Okay. Okay. So runtime attributes, right? I actually want to talk about them a little bit, because even if you don't use behaviors, I guess I can probably give you some tips for actually leveraging that for some really cool stuff. Very common reason why people don't use runtime attribute, don't use InterfaceBuilder. They say when they have a custom UI and custom class, they still need to configure it from code, right? That's like the most common scenario. Like, my UI is too custom, I cannot use InterfaceBuilder. Well, I use InterfaceBuilder quite a lot in Foldify, and I doubt a lot of people have that custom UI as I had in the application. But that's not the point. You can actually use runtime attributes to configure all your custom classes. So if you have a custom UI text field, there was like the text fields with placeholders, because like some classes didn't have the placeholder before. You can just write here, so you can do like placeholder text, and you just enter string. And then when the nib is loaded or a storyboard is loaded, it's going to set that property. And you can do that for all of your properties, because it's using key value coding, so it actually even supports sub-objects. So if your controller has a like lazy loaded other sub-object, you can actually do like sub-object.property and then just put a string in it. So it's really powerful. You can even use it for debugging. So if you have a UI view and let's say you want to configure like the border radius, or having like the corner radius, or having a border color and stuff like that. You can do that from the runtime attributes. So you can get your view controller, and you can set layer dot border radius, corner radius equals like 8 or something. And then you have the whole UI configured from InterfaceBuilder, because many times I see people like, okay, I do InterfaceBuilder, but then I go to code and I configure all these bits when it's not really necessary. You can configure quite a lot from here. The other problems people have, and like example, you have branding. Most of the apps, enterprise apps we work on, have branding, right? They have specific colors you can use, and there are a few ways you can like set those colors in your app. So people usually use code because it's easier. But then if I configure the UI from InterfaceBuilder, I have to go to code to set the colors. I don't like doing that. But you can do what you can do is runtime attributes, because by using key value coding, it's actually calling a method, like it's calling setters, right? So for example, on an app I was working on, I created a method called set color by name or something like that, set color name. And then from the interface builder, I could set background colors, and I could set like tint colors and everything else just by setting a property called branded color. And then I would just use a string, or like light green or whatever the brand name was. And then when the app reloaded, my category got called, and I actually got the code specified in some JSON file or something. But I could use that method from both code and the interface builder, so I didn't need to separate, and I could leverage interface builder. So runtime attributes are very powerful for behaviors. As you can see here, I have like a product spawn behavior. So this one actually, this is from my current app. It's very simple. I specify a list of product bundles, which for our app is like, it's a kids app. So you can like have shop with meat, fish, and stuff like that. So I just specify the bundles I want to spawn. Then I create like the start position. So start creating objects from here. And then what's the offset between the bundles. And it's just going to create new objects for me. So I don't need to do it in Interface Builder. If I want to, for example, add a new bundle, I just add it to the string, comma-separated string. Easier than going in Interface Builder, especially because it's in scroll view. So it actually doesn't fit on the screen. So it will be a kind of problematic to layout it. So I just create that. I can set some settings. And what's really cool, if you are using Interface Builder, that's great for you. If you didn't use Interface Builder with Xcode 6, you kind of lost the benefit, because it brings so much more, because you get Inspectables. And Inspectables don't need to be added on views. They can be added on any kind of objects. So as you're creating in Interface Builder, you're creating NS objects, and you have eBay Inspectable added to it, you get the native configurators, which is great, because you cannot make a mistake in spelling. And what's really cool, it also works cross versions. So they still use runtime attributes. They still use runtime attributes for actually setting that. So if I open in Xcode 6, I get this nice UI. But if my designer opens in Xcode 5, they get the previous slide. So they get this, and the same values will work. So it's really nice. The other thing is lifetime. And if you're creating objects in Interface Builder, so is it a storyboard or is it a nib? There's actually a problem there. Like, I don't like it because it's not the same. So if you are creating an object in storyboard, that object is alive as long as the storyboard is alive. If you are creating an object in nib, that object dies immediately if you don't assign it to some strong reference, which in my opinion is a mistake, because really, like, that's weird. It should be consistent. As developers, we aim for consistency. But anyway, the thing about behaviors, because we will be configuring them from Interface Builder very often, or even from code, doesn't matter. But if the designer is configuring it from Interface Builder, I want them to be able to add and remove behaviors without touching the code, because they don't know Objective-C or Swift. And I don't care. I don't want them to know it, because they will screw up my code. I want them to use visual tools, because that's expressive and that's easy for them. And then I don't get calls at 5 a.m. and like how to fix that. So the challenge here is how can we add and remove objects without touching the code at all? So just using InterfaceBuilder. And this is where reversing the lifetime of the behavior comes in. So we can use associated objects. If you ever use associated objects, you can basically bind one object to another. And if you do, you can do a retain, or you can do copy assignment. So it's quite cool because I can make object A sustain the lifetime of the object B without having any other references to object B, which is really powerful here. Because what I do is basically, instead of the view controller owning a behavior, and then I would have to have a property in code, and that obviously requires code changes, so I have to create it and remove it. I can do something else. I can tell the behavior, this is your owner. And by having different kind of behavior, so for example, if I have an animation behavior that does 5 loops of animation, it knows, okay, this is my owner, I want to be alive as long as I'm executing my 5 animations. After those 5 animations, I don't need an owner anymore because my role is done. And then it just calls release lifetime, which is just setting its own reference, like the association to nil. And at that point, that behavior dies. So you don't use more memory than you need to at any point. And by having that reverse lifetime, in the interface builder, you just drag from the behavior to the controller, for example, and you're done. Then when I just remove that behavior, it never existed. There's no code to clean up. It's really powerful. I'm gonna have a video, so you're gonna see. And there is also events. So some behaviors, it would be nice to know when they actually acted onto something. So for example, I have a behavior for like a Twitter entry. So a Twitter has 100 characters limit. So I have like a character limiter behavior. And then I want to know every time someone types something, I would like to know that I actually limited the number of characters. So it's very simple. If you subclass from UI control, you can use, in InterfaceBuilder, you're going to get all the actions highlighted, so you can connect to your own view controller code. And then from the behavior, you can just send actions for control events, and you can specify stuff. So you can actually do reactive Coco, like kind of behavior by just having actions. So I have like 3 or 4 behaviors that all do different things with, I'm actually talking about like a share screen in my app. And then I connected all of them to one method, and that method just does Boolean operation, checking if the state is correct, and that changes the button state. So I have like visual reactive Coco. It's very simple, and it's very nice. And what are the same sample behaviors you would get? So in my app, animations, like every animation in the app is done by behavior. There's like no code for animations, which is great. Image picking, drag and drop, character limiter. You can do pretty much anything. I wouldn't use behaviors for doing like data-driven stuff. I think data sources and normal composition is better because it just makes more sense. This is more for like configuring what's happening and how you interact with the app. That's why visual tools make sense, because you create it in visual tools and it's visual. But if you are working like a data source and stuff, you can create it from InterfaceBuilder, but that's like normal composition. I wouldn't use like reversing lifetime and stuff like that. And a simple example, so this is a parallax. I'm going to create a simple parallax animation. And the behavior for that is like 100 lines of code, maybe, the class. And this is UI view controller. This is not a custom class at all. Like this is empty UI view controller. There is no class created here. I'm just dragging some image view into a scroll view, some background. It's extremely simple. Like, if my designers can do it, and they really don't know how to code. So I'm just setting, this was done before the Xcode 6. Now it's even nicer because I wouldn't even need to type anything except the value. So I just created the objects, the UI first, obviously from scratch. Then I just drag an NS object. I changed the class to be my animation controller. This was still called controllers. I changed the name because whenever I spoke about controllers, people thought ViewControllers. So that's why it's called Behaviours for a while. And now I just connect the outlets. So I have the like for the parallax, I have a driving scroll view, and I have a target view basically. So a target view is where I apply the parallax effect. And when I run it, I can assign it as a delegate. So the scroll view is the delegate for my parallax behavior. I'm gonna talk that's not limiting. You can have multiple parallax behaviors driven by the same scroll view. It's very easy. And now, as you can see, it's like it was in the depth, so it's different speeds as you scroll. It behaves differently, and like the whole app uses tons of those behaviors, and it's really simple to configure. Another simple example is having the image picking. So here it's just creating an image view, a button, a behavior for actually being able to choose from your image library. And that behavior can configure, you can configure the source. So if you want to allow taking the camera photo, or if you just want to take existing photos. And this is like 50 seconds to create something like that, right? And this is in every app. If you don't have custom UI, image picking, which is very common because if your app is not about image edition, you don't usually deal with this kind of stuff. You just want to grab the image. So you could reuse the code, and that's all, right? 50 seconds, no customs. This is like still UI view controller, no custom subclass. And it works very, very easily. And now you might be like thinking, okay, scroll view is a delegate for a behavior. Well, you can do way more powerful behaviors. So for example, in my app, I have like on one screen, I have like 5 parallax. So I have the background you saw, and there were the windows, right? And inside each window, I have another layer of parallax. And it's all driven by the same scroll view. So behaviors can be quite powerful because you can create, for example, I have like a multiplexer behavior. So I have an object that serves like a proxy. So I attach the delegate to that object, and then I can attach an array of other objects that will just translate to all of them. So I have like that multiplexer, and then I can connect like 20 or 50 parallax behaviors. With animations, you can do stuff like, because it's all configurable, right? So I have animations that like, I have my main menu screen, and I have like different objects appearing with different timing. So it's quite easy because you can just create delays and just configure everything visually. But again, for me, the biggest benefit I saw in this app is I could just create the core gameplay of the application, like the behaviors, like, okay, here I would like to have this, 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 and this. So I create different kind of behaviors. And then I could just commit it. And the next day or day after that, I would download it. And the app looks awesome. When I left it, it didn't look awesome. It looked like, I have no idea how to configure animations and stuff. And they would play with it, and they didn't need me, which is really great because they could just tweak the values, run it again. And then you get the ready product. So if you're in a smaller team, it basically means you can save time and you can focus on getting more out of your app. So getting like nicer features and stuff like that. Or just having some free time while the designers, or that doesn't have to be a designer, right? That can be a project manager or whatever. But it makes it easier to iterate fast. It makes it very easy to iterate fast and adjust for like tweaks and stuff like that. Like I'm really surprised because we don't really have like a pixel pushing session now. Usually when I work on a project, at the end of the project, we always meet up and we have to do the pixel pushing because, oh, we need to tweak that, we need to tweak that. And here I didn't even need to do that, and they just finished the localization, and I'm like, well, are we gonna release now? Because it's kind of feels something, we didn't do something like we usually do. And the app is ready, it works great. We just recorded the video and it looks awesome. So any questions? I'd love to share. Yeah?
So I tend to shy away from InterfaceBuilder for sometimes for reasons like if you just accidentally delete some text field value, like in the runtime attributes, for instance, or if you accidentally deleted an outlet, like stuff breaks in not obvious ways. And with auto auto layout, that became like even more of a concern, right? So if you have designers in InterfaceBuilder and they just move the frame, and you just want to.
I actually taught them how to use auto layout.
Okay.
They know more than I do. But
so anyway, yeah. I mean, so we have designers, and they spend all their time in Illustrator for the most part.
Yeah.
And we collaborate a lot, but teaching them Xcode seems like a pretty far stretch. But you've had success with that?
Yes. So I mean, the question is how do you convince designers to actually use the developer tools, which is like Xcode, for example, InterfaceBuilder? I think the biggest benefit for them, like how could I convince a designer to start using that tool, right? Show them that if they learn the basics, and the basics are very simple, right? It doesn't really require lots of hours. Like you could sit with them for like 2 hours and explain all the basics to be able to do those kind of things. I think the biggest benefit is removing the unnecessary communication. And if they want to change something, they want to adjust some animation, they don't need to bother you, wait for you to reply. They can just go like 5, and it's like 5 times faster or 5 times slower. And just showing them that, like actually not just telling them, because obviously you tell someone, and if they didn't see it, they don't believe you. So it's always like, it's always a barrier to learn new things, right? It's going out of your comfort zone. And I think if you just sit down with them and just show them, like spend an hour or two, just show them, oh, this is very simple and stuff like that. And I can always help you, like just so they are more confident. But once they see that they can actually change it without having to go ask someone for help, and they can see the results immediately, I think that's kind of sells itself. That was like a big sell for my designers. Like, okay, we don't need to ask you for that, and we don't need to wait for you to have time, because obviously you are busy, right? You're working on new features. Yeah?
For runtime attributes, I've used them with UI view properties or layer properties, but I've always had doubt when it's with custom properties. I mean, how did you, I don't know with Inspectables right now, if when refactoring changes everything, how did you, what was your workflow when you needed to refactor a property? Because the change wouldn't be made in...
Okay, so the question is, how do you make sure that the custom properties you set in the runtime attributes are refactored along with your code? Well, my recommendation would be to use AppCode, because it actually refactors those kind of things as well. But yeah, with IB Inspectables, it gets easier, because you could start, like you see that possibly there's a bigger chance that was changed by some InterfaceBuilder. But you could do text search, right? You can do text search in Xcode, and it will find all the properties. I mean, Xcode refactoring tools are a bit crap. So if you really want to refactor, you would still need to do text sweep on your project. But if you use AppCode, which I highly recommend because it's really cool, not for tools, but for writing code, it's great. And it actually searches through all your nibs. There's also the things you can do. It's very simple. There is a storyboard lint tool, which you can use. And this tool is basically going over, like, you can write your own scripts as well, which is quite simple because the new layout for storyboards and nibs is actually usable. But the storyboard lint tools basically checks all your identifiers for segus, for like stuff like that, and verifies. It actually creates like a constant. You can generate constant from your storyboards, and then use those constants. And then at least you have like compile time checking, because you cannot use constant that doesn't exist. So there are tools you can use for that. So simplify. You had a question?
I don't know if I understood. Did you say that when we use storyboard, we can use an outlet, a property of the view controller to control the behavior? But when we use the nib, a single nib, it's better to use an associated object.
So no, the difference, yeah, I understand. So just to clarify, the difference between nib and storyboard is not how you create behavior. The difference is like normal objects, as you create normal objects like NS objects, the lifetime of those objects is different. So if I add an NS object to a storyboard, that instance will be alive until the storyboard dies. But if I add the same NS object to a nib, that object will die unless I keep a strong reference to it.
Okay, and you said that it is better to use an associated object,
so,
not a strong reference.
No. It's not that. It's just the behaviors. With behaviors, you can drag from the behavior to a controller, and that, as an implementation detail, it uses associated objects. So it doesn't matter if it's storyboard or nib, you would use it the same way, but that just removes that difference. It makes it consistent.
Okay.
So because of that, because of using associated object, you don't need to worry about having a property. So you don't need a property from your view controller, because you can ask the behavior to live as long as it wants to.
And as of your knowledge, is it possible in Swift to use associated objects?
Yes, Swift runtime has, like, the Swift compliance to Objective-C is supporting associated objects. Even if you don't have, even if your Swift class is not a subclass of NS object, it will still work with associations. It's really cool because it's like the minimum possibility. Yeah, it makes it easy. Any other questions? Yes, Chris?
How many behaviors do you have? How many different kinds? And what do you think is the most interesting ones? Because you must have discovered some things that you didn't expect.
So in the kids app, I have around 30 behaviors, I think. I have lots of different animations kinds. So I have like rotation, scaling, and stuff like that. I wanted to separate it. I didn't want to have some configuration there. Physics, some of the physics stuff is done on behaviors. So for example, even drag and drop is using physics as a subcomponent. So for example, when I drag and drop in the application and I don't touch the drop zone, which is specified by like a container view, then I get the UIKit dynamics to spring the object back to its original position. But what would be the most interesting? I think the most complex was because I had the normal drag and drop, and then I started working with physics version of it. So the most complex behavior would be the drag and drop that also coordinates with proper physics and stuff like that. But they're usually very light. So most of my behaviors are less than 200 lines of code. Yes?
Is it possible to mix it with data-driven things like cells in a collection view?
I mean, you could even create the behavior fully from code. That wouldn't matter, and you use very simple interface. And again, you wouldn't need to have properties because you can like just call bind lifetime to an object. I use it in some, like I have, for example, in my app, I have like a table for the objects that are printed. So that table is generated from data source, and then all of the print functionality is a behavior. Actually, print functionality in my apps is now behavior. So I have like a print controller, and I just configure, okay, you can print this, and I'd like to make it look like that, and that's just, so yeah, it's not a problem. Because you can use InterfaceBuilder or you can use code. And like each of the bundle has its own behavior as well. So each of the product bundle has its own print behaviors, its own drag and drop behavior. So it's very easy to compose those objects. Any other questions? Okay. So cleaner code, reusability, because you have a bunch of behaviors that are tested. You are ready to go, pretty much, right? I drag it. I start a new project now. I definitely gonna drag some behaviors I already have, and then I kind of saving hours and money. And easy to change because there are small objects. It's easy to evolve small objects, and you can put work on other people. I like delegation. Thank you, and